Hello, I'm Katerina Raheb. I'm from the National Kapodistrian University of Athens, and I'm going to present you the paper Eliciting Requirements for a Multisensory Extended Reality Platform for Training and Informal Learning. Aiming at bridging the gap between the recent advancement in the extended reality research and real-world scenarios, in this paper we describe the first steps of an alternative user-centered methodology developed to elicit user requirements and to design the scenarios for a multisensory collaborative XR platform in the framework of the Bridges project. Two broad application areas have been carefully chosen to span the spectrum of different formal and informal training and learning activities, industrial training for functional purposes, and formal learning for recreational purposes. In particular, the design is led by two pilot implementations. Pilot 1, which targets the needs of applying XR for training firefighters and first responders at two major international airports, one in Greece and one in Germany. And Pilot 2, which targets the museum educators and visitors of a cultural heritage institution in Greece, aiming at creating immersive learning experiences. VR as a reality simulator can be used to place users in a scenario that depicts potentially real events, but in a control setting which alleviates hazardous consequences and can reduce the time and cost burden that real-life drills can place on participating organizations. Repetition time, as well as the feeling of presence that is provided in VR, both have positive effects on task performance, enabling the learning situation to be experienced as a real context. This in turn promotes experiential learning as well as the development of operational and formal thinking by facilitating the exploration of different possibilities. Multiple studies have highlighted the benefit of a VR application in first responder and disaster training, for example, firefighting. The benefits of immersive technologies for learning have been highlighted time and again. In informal learning, especially the domain of cultural heritage, the process of exploring, discovering, interacting, and identifying afforded by virtual environments fosters inquiry that can lead to reenactment, perspective-taking, and knowledge of the cultural, sociological, and even political importance of objects, ideas, or sites. The goal of this project is to develop a solid technological and theoretical framework in terms of technical development, user-centered design, and evaluation methodology for XR. The technical installation, the immersive tech, consists of a set of closely coupled commercial off-the-shelf as well as bespoke technologies and tools assembled into a complete low-cost platform. It includes positional tracking for a group of up to 10 people concurrently. Each user wears a high-end mounted display, which is tethered to a laptop that is carried in a backpack. Inside-out optical hand and finger tracking allows the tracking of hand movements for haptic interaction. This setup enables free roam navigation simply by walking in large, even multiple rooms, and natural interaction. In a nutshell, the key technical and operational feature characterizing the XR platform include a mixed reality setting of any size and configuration, a low-cost solution for tracking the physical area and mapping the virtual world into the built environment, intuitive interaction where hands and fingers are tracked optically and represented in the virtual world, multisensorial stimulus, improving immersion and maximizing the feeling of presence by incorporating effects such as the feeling of presence, such as wind, heat, smell, vibration, in addition to the visual, auditory, and tactile. The methodology is a user-centered approach and consists of 4 different phases: understanding and describing the context, defining user groups, defining and codifying the methodology for elicitation of user requirements, and finally, eliciting user requirements in each category through workshop interviews and other instruments of user-centered design. Eliciting the requirements is only one part of an alternative approach that we follow in the Bridges project. Understanding and describing context or otherwise called a sensitizing study usually involve ethnographic observation on site. In the case of our work, due to the COVID-19 restrictions around Europe, on-site observation was unavoidably limited. Nevertheless, members of our team were able to observe the smaller-scale preparedness drill titled Aircraft Accident at the Airport, carried out in December 2020 at the Athens International Airport. Training drills, part of the emergency contingency plan of the airport, take place annually. To make user group profiles better understood and realistic, we apply the user-centered design instrument of personas. Personas are profiles of people that do not exist in reality, but could exist based on their information that is provided about people who participate in the experiences. Personas allow us to study the actual target groups, motivation, goals, skills, social and psychological aspects of their personality, to foresee their needs, expectation from the experience and context of participation, and take this into account in the scenario design. We developed 3 personas of firefighter trainers and trainees for Pilot 1 and 6 personas of museum visitors and educators for Pilot 2. An alternative approach of defining, refining, and revisiting the requirements has been established. This approach included the coordination of 5 shared and 3 dedicated to each pilot workshops, held in a period of 6 months from November 2020 to April 2021. We have categorized the user requirements into 6 themes as follows: general requirements that apply to any XR experience, site-specific requirements that are related to the venue and its specifications, pedagogical requirements to maximize the effectiveness of training, experiential requirements that are needed for creating a positive overall experience and consider things such as sense of embodiment and immersion, interactivity, and multisensory stimuli, technical requirements that are related to specification of the XR equipment and experience, for example, fidelity of the simulation, and finally, operational and practicalities. As a result, we collected the total of almost 100 requirements and grouped them into the aforementioned categories: pedagogical, experiential, technical, operational, and general. Each requirement was then described and tagged further on the basis of its specific characteristics. This designation and description were revisited and refined multiple times. An issue that emerged early in the process, particularly in phase 4, is discerning the different roles of the users who participate at any given time together in the different XR experiences. The user role describes a classification of tasks that take place within or outside the XR experience and can be held by the same of different people according to their profile, skills, and needs. User roles will differ depending on the application domain of XR. These main roles are the experienced participant, which can be further refined into the trainee or the visitor for each one of the cases, or the pilots, the experienced leaders, such as the trainer of the fire brigade or the museum educator respectively, and also the operator and administrator, who are different roles that can be played by the same persona or different personas depending on the needs and the resources of the organization. This process of listing user requirements has highlighted that balancing similarities and differences is key, and that the points to consider result on several levels. In Pilot 1, the main target group is comprised of a rather homogeneous group in terms of age, skills, motivation, physical condition, and profession. Users are mainly men in excellent physical condition, aged 25 to 55, that share the same profession and working environment. On the other hand, in Pilot 2, staff and mainly visitors of museum, cultural heritage, or other institution can show a great diversity in their age, motivations, interest, physical condition, profession, language, level of interaction and participation, familiarity with technology, abilities, or cultural background. The goal of an experience in this context may also be less factual and more abstract. In addition, it is a question how a group of visitors, whether family, friends, or strangers, should distribute among them the number of redefined avatars and to which extent they should be provided with an option to customize them. On one hand, an avatar with different characteristics may encourage a kind of role-playing. On the other hand, research suggests that being embodied in an avatar with gender switching or voice mismatch may affect the experience of the users as well as the social dynamics of the groups. As noted, the user group in Pilot 1 comprises trainees who must use the platform as part of their obligatory regular training activity, therefore participation is compulsory. On the other hand, visitors in Pilot 2 are there by choice to spend some quality leisure time with their friends and family. Both pilots share pedagogical goals. However, the training in Pilot 1 takes place in formal environment with clear protocols and very specific learning objectives and goals. However, Pilot 2 happened in a more relaxed environment and cultural and educational objectives should be fulfilled in the context of informal learning while simultaneously providing an entertaining, relaxed experience to the users. In this paper, we have presented the methodology of eliciting user requirements for a flexible XR platform that can support multi-sensory collaborative pedagogical experience in different contexts. The process of eliciting requirements, however, as part of an iterative user-centered approach, is an ongoing endeavor of continuous refinement. While a number of studies for VR have been held in the last decades, XR experiences present some unique chances and challenges that are bound to the multisensorial, multi-user, and hybrid nature. The initial set of requirements and their given prioritization serves as the basis for the design of the platform and shaping the use case scenarios. The next steps are the testing of the draft scenarios with real users and the development of the prototype experience that will be evaluated. Ultimately, we aspire to continue with a comprehensive user-centered design framework of best practices that will support designers to deploy rich, immersive XR experiences in various formal and informal pedagogical scenarios and to develop a methodology for the meaningful, well-rounded evaluation of XR technologies, tools, and experiences that can lead to adopt XR as generally applicable at a large scale to a variety of use cases. Thank you so much for your attention.